2 weeks, I have been meeting with great people from this center as well as the Finnish delegates. I'm very thankful for the people who share their time with me and talking about your project. So I really appreciate your hospitality. So today I'm going to share some of my research with you. And unfortunately, some of the video would not be able to show on this machine. So I don't know why. I apologize for that. So in fact, there are quite a couple of them. So yeah, it's a little bit a pity. But anyway, basically, I'm going to give you some briefing on 2 cases that I have been working on for the past few years. The first one is the facial micro expression study. And then the other one is the modeling-based instruction. I know there are quite a lot of experts just sitting here. So I will try to show what I did in Taiwan. And at the end, that was the plan, but today I'm now able to show you the spatial exhibition about the periodical table that I have in Taipei in the museum. And the exhibition lasted for 3 months in Taipei Science Education Center, and now it shifted to the other museums. So for the entire year, they are going to have my products at the museum to attract the public and also to appreciate what the chemistry has been brought to human life. So that's basically what I was planning to do. And I'm also honored to present this exhibition in Tokyo for the IYPT closing ceremony. So I could give you the YouTube link, so at least you could see what I show there later on. Okay, so before we get into all the, before we get into the other 2 studies, I'd just like to show you this circle. Basically for the inter part, that's the English-speaking countries, and Taiwan and the other countries right here. So basically, we are out in the external circle of these language circles. So what do, everybody needs to get used to this. It's like a test. Okay, so according to Tsai's research, basically he reviewed the publications on the 5 major science education journals. And in the past, Taiwan has been well performed internationally because there is a mathematics method to look at this. So basically, I mean, Taiwan is increasing its publicity over the past few years. And then if you simply just look at the other countries mainly, have the English as the major language, or more or less they use that as the secondary language in their society. But what if we break down to the 3 major science education journals? Taiwan published more on the International Journal of Science Education, and then the next one is the Science Education. Fewer people publish there or get accepted for the Journal of Research in Science Teaching, which is the best one so far. So I think there is another signal for us to think about how to, promote ourselves on the top-notch journal, like JAST. So I think you could find the analysis in this article. So we noticed that people are interested in Taiwan's legacy. So they are a book that I edited in 2016. And up to last year, there were about 28,000 downloads. And according to Springer, that was the most popular educational book from the company. So we were very proud of that. So if you are interested in this book, you could take a look. And I also invite the authors to translate this book into Chinese. So they are also available in Chinese. So these are the authors involved, contributed to this book. And after I did that, I'm also interested in showing some of the outcomes from Asia. So I also added another book for the science education research and the practice in Asia. And the downloads was very good too. And you will be able to recognize some of the contributors in this room. So thanks to Joe, Yari, and you could also see some other people here. Like Rachel, she was the visitors here, Talito, of course Yari is here, Joe is here, and also, David Fortas. So we got some flavors about the Asian science education in this book. So now it's about time for me to get into my topic. I like to show this one. I think everybody knows Robert Frost, The Road Not Taken. Okay, so I'm not going to read the whole thing, but I want to show you the last one. I took the one less traveled by, and that has made all the difference. We can only choose one, but I took the one already chosen, so I took this one for facial recognition. So a few years ago, I had a chance to take a group of my students to a conference. And we stayed, everything needs to have a story, right? And this study does have a story to tell. I brought my students to a conference, and we stayed at a B&B. And at the night, we were kind of like chatting in the living room. And I was talking about this TV sequel. Anybody saw this one? I love it by then. And my students also love this TV sequel. So we were chatting about that, and all of a sudden we said, why don't we use this for educational purpose? So after that, we start digging into some of the documents on the web, and also we checked the Web of Science. We found there were very few articles talking about the facial expressions and science education learning. So that's why we started with this, and then we work with more faces here. Ever since the first publication was in 2014. That was appeared on the BJET, British Journal of Educational Technology. And then these are the faces. Of course, when you see them, that means we all already have their permission to show their face. And some of the people do not allow us to show their face. We have several conditions for them to choose from. So these are the ones they could be seen in public. So our purpose was trying to link the science education with the technology, particularly the face reader. So it's kind of like we just try to explore whether or not there is any way for us to understand what students' facial expressions mean something to us when we are teaching the concept. And from the learning theory approach, we always talk about the conceptual conflict scenario will help the kids. So we also wonder in what ways we could diagnose their understanding from their facial expressions. So we basically go through this, and we saw some of the studies, and we find the major facial expressions coming from Ekman's 7 emotions: happiness, surprise, disgust, sadness, anger, and fear. And plus the neutral, then we got 7 emotions. When we have these tours in our mind, and we try to see what kind of the scenario we want to provide in order to investigate these emotional expressions. So basically, in the past, I did a lot of research on conceptual change. And a lot of research also mentioned that given the conceptual conflict scenarios, that will trigger learners' concept, and then they might have the intention to learn something new. So from Hewson and Hewson arguments, they said conceptual conflicts can only occur when both learners' existing conceptions and the concept to be learned are intelligible. So we kind of like want to create something that's really conflict with the students' perceptions. And then it also comes out another theory, which is from the Chin and Brewers. They talk about the responses to scientific anomaly. I think people are familiar with this. You know, when the students face this counterintuitive scenario, they either reject or ignore, exclude, hold in abeyance, reinterpret it, be uncertain, change, all the way down. So when we designed it later on, we also asked the kids, do you believe the scenario we presented to you? Okay, so later on when you see one of them, we even posted a video on the website, and a lot of people saying, no, this is a trick, you know, it doesn't look like this. So in fact, we also asked the kids whether or not you believe it, okay? So these are the theoretical background for learning, and then this for the emotion. So they are kind of like inconclusive findings about the emotion. It seems sometimes you will say the positive emotion will help you to learn something, but some of them says maybe the negative will lead you to successfully understand something. So basically, we got some of the literature, the existing literature saying a little bit different. So that's also something we want to examine in our study as well. So basically, we propose this kind of a theoretical framework. We thought all students' prior knowledge is like a spectrum. Either know nothing, or partially have that, and then you have a complete scientific model. And in order to move the students from no knowledge or partially correct information, and there is a way to help them, which is the anomalous experiment. That's our focus too. I will show you later. And then when you provide these opportunities for them to learn, it doesn't guarantee the students will experience that kind of the counterintuitive experiences. So if they don't get it, then they might just stay here. So they still keep their initial model. But there is another opportunity for them if they have the partial one, and when they don't show their certainty about the phenomena, they might go to the synthetic model. That means they have the scientific model assimilated with their original intuitive model. So it's kind of like a hybrid model during that period of time. And then there's also another chance to go to the end. So basically, we propose this framework, and we hope we will be able to get more data to show this model, to give them some evidence about this model. So the whole design is to use the POE, prediction, observation, explanations as the major framework. And then we also produce some computer simulation to make the concept explicit or to be visualized. And then at the end, we ask them to do some comparisons. So basically, this would be the instructional procedures for our data collection. And the data is coming from this face reader. So basically, we started from 4.0, and now it's 7 already, and we just adjust whenever it comes up the new one. So these are the data. I'm not going to get into that in details, but as you can see, we could also find the major facial expression during their learning processes. So we have 2 experiments designed. The first one is the water reporting. So we have the pretest, and then POE prediction, the phenomena, what will happen, and then observe the phenomena, and then make the explanations. And after that, we have the simulation to teach them what it means for that, what causes that phenomena. And then we have the poster test and the poster interview at the end. So at the end, we want them to compare what the differences between your prediction and the phenomena you saw and the explanations provided by the system. So basically, in the second one, and there's another one, which is the famous kinematic experiment. So let me show you. In fact, you are supposed to see this one, so you just need to imagine. Okay, so I'm sorry, yeah, I just couldn't show up. So basically, this phenomena is you heat it, the beaker, and then once the water inside boiled, then you put on the cork and you turn upside down, okay? And then you put a bag of ice cube on the top. And at that point, the video stopped, and then ask the kids, what do you expect the water will happen when you put the ice cube on the top, okay? So what do you expect? What predictions do you have? It's like my class. So I mean, kids give a lot of choices, right? But I know you have enough background. So the correct, they will see the water reboiling again, right? Because when you put the ice cube on the top, some of the air condensed. So the pressure became lower, so the water, So that's what we did, and this is what you need to imagine. Okay, so we put it on this, and we readjust the kids' facial expression. And for this girl, she was at the, we call maybe, some people call the optimal, maybe Barbara, the optimal learning moment. So we do see the students at that point, her face was like, how could that be? How could the water, boiling? And for the other kids, for this one, it goes all the way to the end without any facial expression changed. We were wondering what's going on. Yeah. So this is the second object, and then this is another famous one in physics. You have two balls here, and you release at the same time. And one goes to the end, straight to the end. The other one goes down and up. Which one goes to the end first? The one in the back, A or B? The one goes a longer distance? Which one? Arrive at the same time? Okay, please raise your hand. Same time, arrive at the end at the same time. Please raise your hand. 1, 2, 3, 4, 5, yeah, okay. And the one in the back, please raise your hand. Yeah, 1, 2, 3, okay. And the one in the front, okay, okay. Why? So the next question for the kids is why, so.
Would you like me to answer?
Yeah, could you?
It spends more time going fast.
Good, okay, good. Okay, yeah, good. And then any others? Yeah. So we do have quite a, before doing this, we also interview the kids to get a variety of reasons. So basically a lot of kids, choose A, but I know you are gifted kids. So, so they will always say either the A or they arrive at the same time, but as I can see, you all answer correctly, you go this way. So you could cancel the first one at the end, right? But during this period of time,
you want to see it?
Oh, okay. Yeah, so during the time, they already got the acceleration when they drop down, okay? So, oh, yeah. You saw it, right? Yeah. Thank you. Oh, yeah, so for the IYPT, I probably could also get it from the website, from YouTube. Yeah, so in fact, we also, yeah, great. See? Yes, yes. So we did this, and in fact, we also posted on the website, and we tried to see how the people react on this. And we got 10,000 responses. We were kind of like, oh, you must be kidding. And there are a lot of people saying, oh, you must do some trick, for this one, and something like that, all the way to the end. That was fascinating, to see 10,000 responses to our video. And we also did that for our students. And since, as you can see, it's only within, seconds. So when we did the study, we let them see the first time, and some people don't get it, right? Too quick. And then the second video was with slow motion. So some people get their facial expression, in fact, at the second time. And the third time is simply just to replay. So we have 1, 2, 3 periods data that we collected, and then the reading the text and also looking at the video. Yeah. So okay, very good. You got it. What we tend to do, and so for this girl, she was kind of like able to show what you just show, what is that? Really? You can do it?
I got to switch back and forth here. So
So, yeah.
It's going to take a minute.
Yeah, no problem when you get ready. So basically, during the past few years, we collect quite a few people from high school and also from the college. So that's what we did. And what did we find? The first paper was published for this research is on BJET, as I mentioned that to you. Because that was the first time for us to do so, in fact, we are exploring a lot. I don't know if you noticed that in the very earlier page, I have a lot of people's figures, the faces there. And as you can see, some boy needs to, pull their hair up because, otherwise you will see a lot of noises. So that's what we got. So for this one, we just try to see whether or not their faces expression changes when they have the conceptual change, or the other way around, if they have the conceptual change, whether or not their facial expression changes. That could be the indicators for us to understand. So that's the first one we tried. Okay, that's a good one. Okay, yeah, okay, play. So, yeah, and for the other girl, she just, no any facial expression changed. So those are the moments we try to get. So now let's, okay, so this is the result we got. First of all, most of the people think, thanks, Bob. Yeah, thank you very much. Around 80% of the students make the incorrect prediction. And for this time, we are not looking at the correct one. If you have enough time, definitely you could also look at the right-hand side. But all the way through, we just focus on the incorrect prediction students. And then after that, then you could see for the incorrect prediction group, the facial expression was detected as changes. And for those people, it's more likely for them to have the conceptual change. If you have facial expression change, that means you were triggered. And so that's why it's more likely to have the conceptual change. But for the people who don't have any facial expression changed, it's unlikely to have the conceptual change. So it's kind of like an indicator for us to begin with. And then after this one, in fact, we did this similar analysis both for the boiling water and the kinematics experiment, and they have very consistent results. So basically, this is the first conclusions from the study one. And the next one is after we do the analysis for that, we publish another paper, basically more in a qualitative analysis. We try to look at students' explanations of the moleculars, I mean the reboiling water, you know. So basically this for the 10th graders and the 11th graders from the local public schools. And the same data as we saw earlier from the same data. And our result shows that for the facial expression changed people, they have a more macro phenomena explanations correct. And if you look at the microscopic concept, they have a little bit more than the no facial expression changed. So in fact, it doesn't show a big jump, but I think at this moment we thought the explanations in the video, as I mentioned that we have a section for the video explanations, and we saw the kids were able to get some correct perceptions from that point. So basically the second article is to look at the students whether or not they could improve their perceptions about the phenomena in a microscopic way. So coming back to this one, and it does shows the students do have some improvement from the far left to the right to develop their explanatory scientific reasoning for that. But just one or two students kind of like to regress. Otherwise, they are traversing to the right-hand side, which was kind of encouraging. That means the students were able to experience the conceptual conflict phenomena, and then they will be able to change their conceptions. And then after that, we also have other study which use the decision tree model to diagnose students' perception, the facial expressions. So a total of 90 high school students. Oh, I didn't come to the. Oops. I go too far. Sorry about that. I didn't go to the research questions. So this was the these two projects. I mean, these two presentations were mainly about the emotions. As you saw the previous one, mainly on whether or not the students' facial expression changed. And now we try to identify what kind of the facial expressions they have. Because as I mentioned that they have 7, including the neutral expressions, they have 7 expressions. So we want to see what kind of the facial expressions could guide the teachers to know that means something to them. Not simply just the facial expression change, but also what type of the facial expressions were. So we have 72 students answering correctly for the phenomena as you just saw, the water boiling. And again, we use the 4.0 face reader, and the statistical software is R. So we use R, the classification, the regression trees, to do the analysis. So there is an algorithm that we need to follow. So basically, that's a new methodology that we try to use. So what we found here, let's go to the other one. You will see, let's go to another bigger one that is more clear. So as you saw the previous one, in fact, we saw some of the students with the surprise facial expression to begin with. So if the percentage is higher than 70.5, then the students are more likely to go to the conceptual change the route will come to here. So if you have surprise, follow up with neutral, that means you are likely to go into the conceptual change. But if your facial expression is for the surprise is less than 72.5, then it goes to the other route. But you still have a chance to be conceptualize, making the conceptual change if you have a negative facial expression. So that means here I need to say something, because sometimes teachers think if the kids get excited and have a surprise facial expression, the teacher will assume the kids know it. But seeing that phenomena doesn't guarantee the students get it. I remember when I presented this at a conference, a teacher at the end, she came to me and said, every time she tried to make the kids so excited, and she was so happy to see their surprising face expressions. But the data shows it's not necessary to have that face to begin with in order to understand something. So if they have they don't really have a strong surprise facial expression, if they show their sad, the negative expression, that means they could still get into the conceptual change model. So the teacher shouldn't be so panicked when they don't see the kids so get excited. So, and then we go to the right-hand side. The NCC means no conceptual change, and we keep dig into that. So the next layer, we could also look at this part. So if they have the neutral, the neutral facial expression, and if the neutral is large enough, it comes back. Sorry. Yeah, okay, sorry about it. Okay, I need to point this one. So this is the discuss. So if you don't have the surprise, you come to the sad, you have a strong sad expression, you go to the conceptual change. But if you don't, that's fine. Under this layer, there's another layer, and if you have discuss, very strong discuss expressions, there is a likelihood that you will reach the conceptual change too. So from here, it seems it implies the negative expressions might play as an indicator for something happening in students' learning. So not always the positive one, but some of the negative expressions also tell us some story about students' learning. So basically for this part, we from the analysis of decision tree models of the current study revealed, exhibiting surprise, sad, or disgust might lead to a high likelihood of conceptual change. That's what we get up to here. And then we keep doing that and start introducing a new methodology, which is the tree forest model. And we try to see whether or not we could have more accurate predictions of students' performance. So we use the face reader 6, and then the R again, and then this is the result. If the students, I need to say something. Here, as I mentioned that, in fact, we have 5 segments. So this, the first one, they just show to the students. And the second one is slow motion, and the third one is replay. So if the students have the surprise at the first episode, and then at the third episode, they have a negative expression. That means I already knew it. Don't show this to me again. So these kids come to the conceptual change. If you keep telling that, they just like, if, for instance, for this kid, they see their first episode, they have their surprise, But come to here at the third episode. I mean, you see again, you still get excited. What does that mean? So for these kids, they don't reach the conceptual change. They kind of just keep. They don't really have a cognitive development at that point. That's what we anticipate. So, but if the kids have a negative expressions and positive expressions for the first segment, in fact, we didn't see the conceptual change for these kids. So, for this part, basically, that's the phenomena we saw at this moment. And then, in fact, based on that experience, we tried something else. We also used R, so I'm not going to get into these. But for this one, it's complicated, but we don't need to look at the whole thing. I just want to show you the study. For the conceptually changed students, we saw the negative expressions happened here. Okay, so for instance, you saw the surprise, negative, and neutral. That's for this group. For the conceptually unchanged group, they have the negative or neutral all the way to the end, or positive or surprise. So I think to some extent, the teachers shouldn't be so nervous about students' negative facial expressions. Maybe they are engaged in your teaching and they try to process this information, and it takes some effort. So that's why we saw some of the data here. And for this, I will just skip these words and then get into the most current one. And now we just submitted one article to the, I think to RISE, Research in Science Education. So basically, we just try to see whether or not the students have a higher or a lower prior knowledge, whether or not that impact their learning, and what's the likelihood of conceptual change. So we did this similar study again, and the correct prediction was 24, incorrect prediction is 116, and we use them as our major subjects. And again, we use R to analyze our data. So basically, the major finding for this one is quite consistent with what we saw earlier. So these are the negative. The bigger N is negative, negative, negative. So this will lead the kids come to the conceptual change. And if they have the negative, if they have the negative here, all the other signs are representing the neutral or surprise or positive or negative. So if you go to the, this for the higher achievers, if the higher achievers with the negative facial expressions, that brings them to conceptual change. However, for the lower achievers, if they have the negative facial expressions, it leads to no conceptual change. So in that way, higher and the lower performers, they perform differently. Because for the higher one, I think it's more engaged in the learning materials. But for the lower one, they just kind of like, they don't understand. So in fact, we try to use the other tools to do the triangulation besides the interview. We try the, how do you say that, the temperature, skin temperature, and the breath wave, but difficult to really, because the temperature would not change that much, right? So currently, we just use the data for analyzing this kind of performance from the students. So I think basically, if we just look at the facial expression studies, I think these are the ones currently, we found the diverse facial expressions have been shown, and the negative ones were very promising and consistent. And I think that this could also have some educational implications, because I think the teachers should be aware of this. And in the future, we also hope in the classroom, if there is some diagnose equipment could be installed, maybe the students with this kind of expressions, maybe the system could be automatically provide the scaffolding materials. So that's pretty much the one I want to share with you for the, oops, did I go the wrong way? Oops, sorry, oh, sorry, yeah, I go. Yeah, that's pretty much for the facial expression study. And oops. And then I want to show you the other one about the modeling. So I'm going to go to the other one. I took the one more traveled by, and that has also made all the difference as well. So I'm going to show you the models in the modeling science education that those studies have been conducted in Taiwan. So I think people are familiar with this, and this was also some background, the motivation for me to do this, because as we can see, the students drop their engagement of science over the past few years. This data is to compare the PISA 2015 and 2006, because these 2 years are mainly major students' science attitudes. So as you can see, a lot of countries, they have decreased engagement in science. And again, I also did some comparisons of students' expectations of a science-related career between 2006 and 2015. And as you can see, a lot you could find your country, but if you look at the left-hand side, that's higher. So these are the countries with probably lower economic human development index. And for the other who perform well, they have lower scores, as you saw on the other day. So basically, this is also some motivation for me to do it. And I shouldn't say anything more about the NGSS to you. You know more than I do. So I just want to point a couple of them. The system and system models right here explicitly stated. And in the practice, basically, you want the kids to use and developing models and the constructing explanations with some evidence. So that's pretty much the literature existing now that we could use as, to back up our research. So what does Taiwan react to this trend in its curriculum standards? So basically, we have the elementary school for integrated science. And for the junior high school, we have biology, physical science, earth science as the major subject. And it's now required to have the integrated courses for middle school. And for the high school, for the first time, we have the inquiry and the practice course for 4 credits. All the students need to take this course. So the teachers are facing the problems, what kind of the courses they need to give for these 4 credits. And the book publishers are not intending to develop the textbooks for the schools, because the government encouraged the schools to develop their own curriculum. So now there is a high demand of exemplar materials for the teachers to use. So it's a time for researchers to work with teachers to develop some of the curriculum. And that's what I saw here. You emphasize on this. And also, Taiwan has thinking competence and the problem solving as the major learning performance. And within the thinking competence, constructing models were explicitly stated in the curriculum standards. So these are the performance we are requiring to be developed at the different levels of the school years. And for our curriculum, we do have the subject. I think probably this is a little bit different from NGSS because we have the topic, and we have the subtopic, and then the learning content, and the details of the concept to be taught, and also recommended hours for this concept. And the purpose for that is to help the teachers to organize their curriculum. So we have the learning performance, and we also have the learning content, including the sub-contents. However, for the learning performance, it doesn't really have details for each unit. It's like just overall, you need to have this learning performance. So if we are talking about the unpacking, maybe what we should do, I mean, for Taiwan's part, we need to unpack the learning performance that would be aligned with the learning content, okay? But for the learning contents, we have the details, a list of the detailed concept to be learned, but we don't have the details for learning performance. So that's a big difference. So now we need to do is to align them in order to make the units more appropriate for the school teachers to use. And I was invited by the Center of Chemistry, sponsored by the Ministry of Education, to develop video tips for the high school teachers, because people do not know what we mean by modeling or nature of models. So in fact, they helped me to develop the 11 movie clips. So that was very helpful because, I mean, the teachers told me, each one only 3 minutes. And teachers told me that's the time they could tolerate. So they break that down, I mean, originally 30 minutes, and they break that down into 11, and they say that was a great strategy for them to stick on this. Yeah, so I think that was helpful for teachers to understand. So when we did the modeling, we go through the Johnstone's models and also consider the human element from Peter Mahaffey's. And then during my research, I also noticed Mandarin also helps students to learn the concept. For instance, if something compound, if an element, a chemical element is a metal, and once you saw the character, you got a hint from that character. So that also helps the kids to learn the concept. So I thought that could be one aspect to be highlighted. So basically, when we design the curriculum, we follow this kind of approach, getting from the phenomena and the macro spot, and then go to the structural models or submicroscopic representations, and then finally, everybody is familiar with the Johnstones, and finally, that's the symbolic representation. Particularly, we use the multiple representations to help the kids construct their knowledge about the phenomena. And we also looking at how students understand the model from ontological perspective, what the model is and which properties does this model have. And also from the students' epistemological perspectives, when and why and where we should use these models, and finally, what the functions of the models are. Why should we use this model? Okay, so these are the framework we use, and recently we also developed this more comprehensive structure for our research. And we thought, when we talk about the modeling competence, we want to split the knowledge and the practice apart. So the one I just mentioned, the modeling knowledge from the ontological, epistemological, and the methodological perspectives. We need to develop their concept. And then for the practice, they need to use this knowledge into a practice. And then for the practice part, we want to let them know the processes, what the process they need to go through from developing the model and elaborating the model or evaluation, and then apply the model, and finally to reconstruct the model. That's the process they need to go through. And also, we want to look at the product. So for this one, for the practice, we really want to look at two things. One is the process you go through, and what the product you have. So that's why we normally look at the students' mental models of a specific phenomena. And then finally, that's the metacognitive knowledge of models and modeling. How do you know about the nature of model, and in what way, and how do you plan to make the modeling processes work, and how to put that into practice. So basically, this is the structure we plan to do. And there are quite a lot of studies talking about the importance of modeling. And I think one thing I want to highlight is the lacking of enough assessment tools to evaluate students' modeling competence. So I think this is a very good area for us to explore, because the different tools measures different things. And what would be the most appropriate way to evaluate students' competence on modeling? So that's the major message I want to bring to you. And the other one is the textbook do not make the appropriate use of historical and epistemological models. So in our textbook, we try to rewrite it, and we rewrote the textbook based upon the modeling processes. And that one has been published on Science Education. So if you are interested in that, I could send you the paper, or you could find it on the website. So I think there are quite a lot of experts doing the research in this field, and they are very enlightening. And Christina, Joe, and are here. They are very prestigious. Yeah. So what I did for my modeling research, I started with I will give you some example later, but now I just show you the trajectory of my research. So in the beginning, I just tried to develop some survey to investigate nature of models. So that came from Grosslight's research. So I developed some questionnaires, and I tested different levels of the students. And also I also have a student did this in Japan. So we also have some data to be compared. So all the way through, basically, I just tried to modify my model about the modeling processes. So as you can see, originally we just have all of them listed as a procedure, a sequential steps. And later on, all the way to here, then we kind of like to split them into 4 stages. So that's what we did. So after we did this, I developed these modeling processes. I work with students, and I also work with teachers. Later on, I will give you an example about the fruit battery. So we did this in the schools, and we work with the teachers, and we were able to host. We had the curriculum competition during that period of time. And probably this one cannot be seen either. One of the there are several activities. On your left-hand side is to use the bigger and the small styrofoam. So you use the hair dryer at the bottom. So once you change the amount of the gas, the air to get in, and they could see the movement. So it's very simple, and the students could make their own model, and they could test a lot of hypotheses. And on the right-hand side, that's to teach the students about the random movement of particles. So on your right-hand side, that's a role play. So we let the kids standing at the corner of the classroom. Boys stands for the blue dyes, moleculars, and the girls stands for the red dye, moleculars. So we ask them to close their eyes, and then we just say, okay, now you have 1 minute to move. So they just move around. So originally these are the red dye molecular, and that's the blue one. Put into the water, for instance, right? Put in the water, and then they spread out. What we did was we asked them to do the role play. So once after 1 minute, everybody is surrounded by different people. So that tries to teach the kids. I mean, when you see the red molecular moving towards this direction and the blue one moving towards this direction, that doesn't mean they have an intention moving from one side to the other side. That description is at the macro level, not at the micro level. So we ask them to play as the molecular. And once originally they are, having the friends surrounded with the old girls, but at the end it's different. So, Bobby, you're marvelous. Oh yeah, there. And you could, yeah. Yeah, originally they were standing at the two corners. Yeah, you could play. Oh, okay. And you could also look at the left-hand side. That might be the easy. So we also did, that one is for high school, but we also did that for with the elementary school students. And the kids, the elementary school kids, they wear the hat. The boys wear same color, like a red color, and the girls wear another color. So, even fourth graders, they will be able to generate the particle models through these activities. So I think if we could get these activities explicit and meaningful to them, they would be able to construct that, very difficult or complex concept through these kind of activities. Yeah. Thank you, Bob. And so we have been developed several activities for the kids to do it. And basically, we try to use this model. They develop the model, they elaborate or evaluate, then apply, and the reconstruction. And in fact, when we did the teacher training, we have two sub-steps for each stage. And when we did the teacher training, teacher says, too complicated. They couldn't follow it. It was difficult for them to differentiate model selection and the construction. So after we did several times teacher professional development workshop, we decided to use 4 stages to teach them to construct their own curriculum. And for our research, we will get into the 8 steps rather than, so I think we also learned lessons from doing this. Teachers we could not give teachers too many complicated things. We want something feasible and they could use as a framework to develop their curriculum. So ever since we just use we call the DEAR, development, elaboration, and the application and the reconstruction. So I think this is manageable and feasible. Okay, so this article is going to be out on the a new journal which will be launched next month. It's called the Disciplinary and the Interdisciplinary Science Education Research. So coming from the Joe's driving questions, so we think for these activities, no questions, no modeling. So we need to have a scenario, a question or a phenomena to begin with, and then students will be able to be guided to use their knowledge. So we call this is a DEAR model. How long should when should I finish? I should leave some time for people to ask questions. 5 minutes? Okay. So thank you. So we work with the high school teachers on the fruit battery. I think everybody knows this, which is very popular. And then we work with the teachers, and as I mentioned that earlier, we rewrote the modeling-based text. So the main purpose is to ask the kids to find the components of this system. What are the components to build up this device, and what the relationships among these components, and then how to make this as a system to work. So we try to guide them through these processes to build up their own models. And then the regular texts do not have this. And the reason we use this was because we developed this kind of text before for the 10th graders. And that was published on the Science Ed, and we thought that was very successful. So that's why for these teaching materials, we basically follow that. So for our assessment, let me come back here. Oops. Sorry. For our assessment, since our instructions focus on components, relationship, and the system, how to make the system works. So we have the components items, and we have the relation and the system items. As you can see, and the tour is 0.8. So the students need to design a device that could allow the mechanism, the chemical reaction occurred. And then we will ask them, please mark the poles and what the A and B means. And so gradually we ask them the components, and then we also write down what the half reaction cells are and what the full reaction formula would be. And then how does the whole system works, where the electrons go, and how that makes the whole device works. And we also have extended questions for them. How do you make this device more efficient? And what kind of things you could do. So basically, we have several questions or more advanced questions to ask them. And then we evaluate them according to this rubric. So kids need to express their competence in terms of linking the variables together and building up the systems, and then also be able to provide the data to support their explanations. So we have these 5 layers to evaluate the students. So basically, we have quite a lot of nice result. I mean, for the control group, of course, not performed as well as the treatment group. And as we can see, the treatment group performed much better on the system part and also the component. But for the relationship, you didn't show up the significant difference. Maybe we could skip this one, but basically, if we look at the each individual procedures, the treatment group performed much better on these 3 aspects. So because we did this kind of a design, so we were able to, I'm not going to get into this one, but I just let you know what we did. We used this as a rubric to investigate students' mental models. So not only the quantitative data we have, but we also developed the criteria, the coding scheme, and analyze the students' mental models of the redox reactions. Hopefully I will have time next time. I could show you this one. So we did some analysis on the students' performance as well. So I think probably I should stop here so we could have more questions from you. And I think basically modeling process, modeling competency is something we need to develop to the students. And then I think a lot of people are doing the effort And I think that's the right direction, and it needs a lot of people put efforts and wisdoms to help the kids to appreciate science and enjoy science. So thank you very much for your listening. Yeah. So maybe questions from you? Anyone? Yes? Carl?
For the presentation, the space freedom part was very interesting, and I highly valued your
Thank you.
research design. It was very interesting to combine this learning and these emotions.
Oh.
And my finding of it was very great to see that there are perhaps benefit for learning also those negative emotions. That was
Thank you.
it was important finding.
Yeah. Okay. Thank you very much. Yes, Katarina?
Yeah, I also enjoyed very much. So I was also following from what Kalle was saying, that I think we really should think about combining this optimal learning moment idea and this, that's like aha moments and the face reading, because we are using it as well. So
Okay.
it would be nice to collaborate and think
Yeah.
about it. So thank you very much.
Well, thank you very much for the comments. Thank you. Yes, David?
So I'm wondering if you've thought about what some of the facial recognition work might mean for pre-service teachers. So, for example, tomorrow I have to go teach my methods class. Okay? I have my little baby teachers there. Are there some lessons that you've thought about for new teachers in terms of understanding how to read students, or whatever you want to frame it in terms of how they should learn to recognize when they're really engaging students or not?
Yeah, okay, that's a very good question as well. I think basically the pre-service teachers do not really know how to develop a conceptual conflict scenario to begin with. I want to start with that because I think design a counterintuitive scenario is also a very powerful strategy for teacher to use in the classroom. So for that design, I think maybe the pre-service teachers could learn from that to begin with. And then the facial expression, I think we need to have some waiting time for students to respond. And also, I think, as I mentioned that earlier, surprise doesn't really guarantee the students will learn the subject. It's different, you know. So like we see the fireworks, we are so happy about that. But nobody will think about any chemical elements in it. So they think, when they talk about the chemistry, they will always think about the bombing or, you know, or negative, but they never thought about that. So I think, I just think, you know, a lot of things that we could help the kids to learn something. So surprising doesn't really mean learning. And the negative facial expression really help the pre-service teachers to be aware the responses from the students. We think that facial doesn't really mean they don't follow you. So don't get upset. You know, sometimes we always like to see the smiling faces, but I think that's something I learned too. So I think the pre-service teachers could also learn from that. Yeah, thanks. Yeah, Christina?
So I'm really interested in following up on this and wondering about the implications for lots of different classroom environments. So I'm going to be a little bit controversial, Mei Hung, and I'm going to say that I'm a little bit worried about the implications of your facial recognition software for teaching in large classrooms. What I've noticed in large classrooms, I think it's extremely useful to know how to read faces and recognize, right? That's a very useful thing. However, I also think that it's really important to talk to students. And if identifying faces means not talking to students and finding out what they really think or really do, I worry about that. So I'm wondering, and I notice there's a hesitancy often in science and math classes in particular to talk to students and find out. Typically, especially at the college level, it's easier just to give tests. And I say, well, why don't you talk to students and find out more about it? And there's, well, even if I talk to one, that doesn't, right? But it's very useful to find out what they're thinking and doing and how they're responding emotionally. How do you balance out this idea in your research between recognizing faces and the actual work that's going on inside of them and how they're feeling and responding?
Yeah, that's a very good question. In fact, human beings are very complex, right? Sometimes even when we are teaching, we want them to show their smile face. That means they are following us, right? So, and also the other thing is learning also deal with puzzling. And I don't know, but for this software, it's a limitation. We keep asking 3 years, ever since the beginning, we asked the company, could you produce a database that we could use for puzzles? Because that's a very important facial expressions to me. So I'm not going to overgeneralize my study. That would be a very dangerous thing. Of course, we need to interview the kids. We need to have other tools to, really say something about students' learning. But for our facial recognition tool, it does have limitation. They could not even say something because they would change the mouth, and you would recognize. You would be recognized as something else. So for us, we did the interview at the end, not in between. So I think all the tools have limitations that I have to admit. And from the tool we use, that's the conclusion we could come out. But if you really want to adopt that into a big classroom for a lot of varieties, including discourse between teachers and the students among students, that would be something different. Yeah. So, I understand it's very difficult to adopt that in a real world. I would just say that's more like the experimental study, that we need to control. Yeah, thank you. Yes?
So for that experiment, you were relying on visual cues. I was wondering how do you think it could change if you're relying on like auditory cues? Because I'm thinking, for instance, a blind student still can have facial pattern changes, but they're obviously not going to be responding to seeing the ice pack and the water boiling.
Oh yeah, right. So for them, then the tool should be different completely, because when they register the facial recognition, the facial expression, they need to have a lot of dots here, and for them, their eyes cannot be recognized. So maybe they should be used. We should use other tools to help them. Yeah. So as I mentioned, that we couldn't, overgeneralize the result. That's the limitation of this. In fact, we tried the brain wave and eye tracking. In fact, we do have some data for eye tracking when they have the facial expression diagnosed at the same time. But it's just, we try to do the triangulation, but it's just too challenging. We have some data we haven't analyzed. We tried 7 kids. It's very difficult to put everything together. That's very ambitious. But hopefully we could have more results to share in the future. Yeah. Yes, please.
Could you review for me one more time when you said under certain circumstances there was the evidence of conceptual change? What was the evidence that you were actually looking for, indicative that the students were undergoing that conceptual change that you may have?
You mean sometimes I look at the facial expression changes, and the other thing is we also look at what's the major expressions for that period. Because we have a continuous data right there. So we could identify which point we want to see, and then we could see the peak of that facial expression. So it could be during that period, surprise is the biggest one, or the negative would be the biggest one, and how that impact their understanding. Yeah.
And you're interviewing them, or they're doing an assessment?
No, the interview is at the end, all at the end, and the pre-test and the post-test were on the screen. So in fact, we could also look at the pre and post test to look at their facial expression. Whether or not this is very difficult to answer, but just too many data. So currently, we have the video 1, video 2, video 3, right? And then the reading the text. We have a short text to describe the theory in that phenomena, and then the simulation. So in fact, we have 5 periods of data that we could analyze.
And
so,
the pre-test
and the pre and post test. And the interview, definitely, we close this up. It's not on the computer. But for the whole thing, all of them are presented on the screen. So students just start answering that. And the Chin and Brewer's 8 stages, we also put that on the screen. So kids just click, I agree or I don't, yeah. So during that period, we just cannot interrupt them, yeah, due to the limitation of the software, yeah. Yes, Pen?
Yeah, I have a question because now Taiwan have already released the new standards for the certification. And you mentioned the modeling-based instruction, you do a lot of practice work. So my question is, now your modeling-based instruction, how to align the target of the standards you mentioned? It is the inquiry competencies, and the dimension of competency is the problem solving and the creative thinking. I mean, how's the
for these learning outcomes or learning performance, basically it only has a very wide descriptions that should be achieved at a certain grade. For instance, you need to build out the model and provide explanations. And some of them would be just look at the data and build out your model. So the levels are different. So currently, we go through the 4 stages. I mean, for our research, we try to help them to construct their own model and then try to test that out and also design their own and try that out and try to verify it. And we didn't get to the 4th stage because that's the reconstruction whole thing. That was difficult. Because unless your theory changed, for instance, you have a formula for ideal gas, and then if you want to try the real gas, then that would be different, right? So that would reach to the reconstructing the model. But when we are talking about the personal model, then they will reach that. So one is for the theory, the other one is for each individual. So they will go through these stages and then try to build up their model. So when you talk about alignment, I think basically the curriculum is kind of like just give a rough and very broad definition about modeling, yeah. And for us, we look at something more in details, yeah.
It's kind of like in the US, the NGS performance expectation is we call the knowledge in use. So we assess the knowledge in use to refer to the PE. So in that way, it's because the Taiwan standards talk about the inquiry competency. It's kind of like the knowledge in use standard.
Yes.
In that way, the modeling based instruction can help to students development of the inquiry competencies.
Yeah. So we thought the 4 credits for inquiry and the practice for the high schools provide a great opportunities for us to do some experiments in schools. Yeah. Thank you.
We want to thank Mei Hung for
thank you.
very thorough presentation.
Oh, okay.
We have gifts for you. Thank you so much.
Thank you. Thank you for coming.
The next Create Seminar series is, I don't know where Sue is.